For us, the storm has passed. The war is over. But let us never forget those who journeyed into the howling dark and did not return. For their decision required courage beyond measure, sacrifice, and unshakable conviction that their fight, our fight, was elsewhere. As we start to rebuild, this hillside will remain barren, a memorial to heroes fallen. They ennobled all of us, and they shall not be forgotten.
Present! Hops!
I remember how this war started, what your kind did to mine. I can't forgive you, but you have my thanks for standing by him to the end. Hard to believe he's dead.
Were it so easy.
Discovery, go at throttle up.
All right. Happy Memorial Day, everybody. How are you guys doing today? Let's go. 41 months. There you go. How's everybody doing? Man, feels like I haven't been here in a little bit. But, yep. I think it's important, just on a side note, to... I mean, I don't know if this is a thing. If you're from overseas, don't know if it's a thing.
Go at throttle up.
If not, disregard this part, but it's always good to pay tribute to the fallen. Yeah, it's something that's important, and it's important to remember. You don't need a day every year to do it, either. The same, I know the difference between Memorial Day and
Discovery,
Veterans
go
Day.
at throttle
But
up.
keep that in the back of your mind. It's important. Thank you for being on. I thought I was gonna have to watch cooking streams all day. Oh, okay. What about you, Mr. Strimmer? I'm all right. There's a flag retirement bin at the local fire station for old weathered flags. There's a protocol to fold the flag up into a triangle before putting it in the bin.
Discovery, go
You
at
don't
throttle
need
up.
to, but you should, but you don't need to. You should. There's flag code for that, Mayor. Yeah, you can go read the flag code. 6265, 36-month resub. Elro, how you doing? Cooking Fat, 11-month resub. Thank you. I'm good given what's going on. All right, there you go. Yeah, don't. Yeah, exactly. Tugboat, don't ball it up. Exactly. Yep, proper flag disposal. Every flag at the end of useful service life should be burned. That is, as is tradition. But, yeah. Or cut the stars from the stripe, then burn them separate. Yep. Yep, there you go. Alright, anyway. Yours isn't there yet, just make a note for future reference. Yeah, mine, here, let me see. Mine's still in good condition. Mine's still in good condition. I bought this one, I bought this flag on July 4th, 2021. The reason why I did it is because no one could go outside. And that sucked.
Discovery,
Everybody had to
go at
watch the
throttle up.
4th of July celebrations on TV, so I felt it pertinent to buy a new one. Hey, SBO. 3-month resub. Thanks, man. Damn, already 3 months. Hanging on your first owned house. I do. It's hanging in my garage, Sun Temple. I assume you've heard the low bay. Yeah, the low bay is gone. I heard about that. They're going to expand, which is pretty cool. Alrighty. You enjoy the news around all the teams talking about the Red Bull underside floor arrow. Yep.
Discovery, go at throttle up.
Maverick gifted a sub to Harambo. Did you see the Monaco race and the Indy 500 pit stop errors? How about the tire going into the stands? Dude, did you see it hit that car? That car, though, Chevrolet. Oh, boy. Yeah, here we go. This is from, this is the Lab Padre stuff. Yep, They brought the breakdown. Old school. End of an era, isn't it? Did you hear she had to have it towed? Yeah. Dude, I mean, that thing got messed up. I'm just happy that that wasn't a person, man. Yeah, you see the wheel go into the stands, dude. I saw it and went... I'm like, oh no. I'm not American, but I respect this day. Thank you. Ground fab and propulsion buildings are also going down. Yep. Yep. Big expansion. Big facility expansion at, oh my god, I need coffee. I mean, how about Kyle Kirkwood's crash, dude? Car's just like, hey, I'm just going into the wall. Oh, you're upside down now. Have fun with that. He's in the car just going, okay. All right, I guess I'm upside down now. Like, okay, that happened. Thank you. Thanks for coming out. All right. Dude, congrats to Newgarden, though. That was money, dude. That was a money drive, but Ericsson almost had it again, dude. It was great. Yeah, so SpaceX is basically demoing all these buildings right here. 1, 2, and 3. They're going to expand. They're expanding their indoor facilities over here. This is basically all going to be one building. It's going to be a sad day when the 3 tenths go down. It's going to be a sad day. Let me see. What's this footage? Ricardo. Coming from Ricardo here. What's this? I got you, Phil. Okay. Hell yeah, son! Oh, that just made my day. That guy was into it. Yeah, no, kind of into it too. Definitely about that life. I'd be like, yeah, timber, you know. Fell into the swamp. Yep. Hell yeah, son. How'd you like the races yesterday? I was on the beach, man. I was on the beach. Look at this farmer's stand that we got going. Look at this. Look at that. I was on the beach. Oh yeah. Look at this. This is great. Look at that, huh? Oh, isn't that fantastic? So Starbase Gigafactory. That seems to be what's going on, Maverick. Yeah. That's the attitude you approach with your job, indeed. Indeed. Yeah, we got the farmer's stand. Dude, I had Coke 600 is today. Yeah, that's right. Yeah, they postponed it a day because it was raining. Moonshine as the Coast Guard? Wait, what? So I had pretty much Bree and I had our entire family down at the house for a Memorial Day barbecue, and my neighbor had a lot of people over for a Memorial Day barbecue, and me and my neighbor, the cool neighbor, we were like, we just combined it into one big freaking. It was one big, gigantic honking party. It was great. Great party. Went from like 2 p.m. to like midnight. It was nuts. So, have you ever tried welding plastic? No. Farmers stand for the win. Indeed. The tire went over the fence. Dude, I saw that. I saw, dude, and it hit a Chevy Malibu. or was it a Chevy Cruze? I don't know. So, we had this crazy weekend, right? And so, me and my uncle, the guy that I bought the 59 from, and a couple other people, a couple of the neighbors were talking about the cars, and they were like, hey, AJ, why doesn't the blue one run? I go, there's ethanol stuck in the carburetor. And I'm like, all I got to do is just rebuild it. I just got to rebuild it, so it's not going to take very long, but I can get that up and running. And then my uncle's like, why don't we do it now? I'm like, why don't we do it now? So cracked a couple of brews and rebuilt a 2-barrel carburetor. And we got the Coronet up and running. Dude, it's straight pipe, so freaking we fixed the carb, made sure everything was good. My uncle's like, this is how you tune the carburetor. I'm like, I know how to do it, but I learned a couple of tricks here and there, you know, like, so we tuned her out, filled up the tires, and then took it for a spin around my driveway during the party. It was nuts, man. It was fun. It was a good time. Was that barbecue watching the races? No, that was Saturday night. So Sunday I was on the beach, man. The president of the track took care of the lady whose car was it. Yeah, that's fair. That's fair. So, yeah. All my cars run now, by the way. Like, everything runs. The Coronet's tooled up and ready to go. The brake pedal's a little spongy. We have to fix that. So, yeah, the Coronet's all fixed. So there's that, and the truck is good. I just got to put the seat in. Yeah. Not bad. So yeah, that's what I did. I was on the beach during the races, so I didn't get to see exactly a lot of the race, but I did end up watching them later, so that's, all my cars run, just don't try to make them stop. So what I hear is new project car. Don't get me wrong. Most of my cars are project cars. The truck, the 59, ironically, Dave, is the one that's the furthest away from being a project car. That's, okay, out of my fleet of junk. Coronet needs new brakes. Yeah, probably. I'm good, Liglander. How are you? Alright, so yeah, that's what I was doing, but I did see the races. I saw the tire go into the stands, and I went, please don't land in the stands. It missed, though, thankfully. Hey, Tristan, what's going on? You wouldn't have junk if you stopped getting furs. Dude, the entire rest of my family is all Chevy guys. So, I was getting it left and right the entire freaking weekend. Are there fairly inexpensive disc brake kits for it? Define fairly inexpensive. Yes, for the most part, but also expensive. There's a lot of stuff you have to change when you're swapping the discs, but she'll be fine with the drums for now. I honestly think I just got to tighten the lines, because the pedal still stopped the car, but it stopped the car at the very end of travel. So that means that the brakes still work. Everything works. There's just air in the lines, and that usually comes from not tightening down a fitting all the way. To be honest, you're a fan of Ford trucks. I think Ford makes a better truck, but GM makes a much better car. I mean, well, yeah, because Ford doesn't make cars. Duh. If Ford did make cars, they would make a better. Hey, I got you there, man. I got you there. I got you, boy. I got you, man. Oh dear. All right, let's see what else we got for space news. Here we go. We were talking about Farbase. Goes far, get it? There's no way it came from the movie. As a non-American, I'm curious, what do most people on Memorial Day do? Ugh. What do most people on Memorial Day do? Party or visit graves? I visited my grandfather's grave. That's what you should be doing, but mostly nowadays people just use this as an excuse to barbecue, which is okay. Everything shown in red is in the process of being disassembled. Green is the beginning of Phase 2 Starbase Factory expansion. Yeah. They're going to go down this way, and then they're going to go over. My daily driver brake's okay, but I can relatively easily push the pedal all the way through. I guess it's time to get the brakes checked. Flush the brakes, Kinder. Okay, so open up your brake cylinder, the brake cylinder reservoir, brake master cylinder reservoir. Open it up. Look in there. If the fluid isn't clear, like crystal clear, like water crystal clear, change it. Suck all the fluid out with a suction cup or some type of pump, and then just pour new fluid in. That's the quick and dirty way to do it. Brake fluid is hydroscopic. It absorbs water. It absorbs everything. So unless you store the car in like a climate-controlled garage, right, where, you know, the sun doesn't beat up on it, and then at night, and then sunlight, and then night, and then sunlight, it's going to condense water in the brake line, and it's going to condense and evaporate and condense and evaporate and condense and evaporate and condense and evaporate, and all the, it'll basically, yeah, pick up all the crap from that. And yeah, brake fluid should be clear. It should be crystal clear as water. If it's not, it's junk. Today I can't help but think what great grandfather saw in Belgium in 1918. I'll admit, dude, Memorial Day always bums me out a little bit. It's not really a day you should be celebrating, per se. But, hey, you know, it's just important not to forget. So, like, dude, once again, if you're watching this from overseas, your country's probably different. It's fine. But here, you know, we remember people, we remember the, you know, our service is entirely voluntary. There's no conscripted forces in the United States. There hasn't been since Vietnam. You know, so everything is done voluntary. So these people are willing to lay it on the line to keep my freedoms, or keep me free, right? I that's something I don't take very lightly. The fact that somebody I've never met, you know, has the stones to do something like that is very meaningful to me, and it's something that, like I said, I don't take it lightly. Yeah, that's all. That's it. You know, so it's not really. Today is remembering people that paid, that, you know, that watered the tree of liberty, let's say. Founding fathers quotes. It's important to understand that, and it's important to keep that in perspective. It keeps me honest, you know, keeps you honest. That's important, especially in this day and age. There's a million vices all over the place, and I am very susceptible to addicting things, just like everybody else, and that kind of stuff keeps me honest, you know what I mean? Same here in the UK, but I don't see us as patriotic or caring that much. Yeah, I've seen people do it. Like, yeah, it's not as prevalent over there as it is over here. I'm ex-Army, and here in the UK we have Poppy Day. Yeah, there you go. People confuse Memorial Day and Veterans Day these days. Exactly, twisted. Veterans Day, you thank the people that are still here. Memorial Day, you thank the people that aren't still here. There's a little bit of a difference. There's that whole living thing. Yeah. Here in the Netherlands, we have the 4th and 5th of May. Yep, there you go.
Discovery, go at throttle up.
Hey, Hidgy. What's going on, man? 79 months and flyking with a 42. 42 months of impressively
Discovery,
entertaining,
go at
educational
throttle up.
father-like. Thank you for these 42 months. And I hope that many, many more. One MSC. I don't know, maybe. Or not, 69. Nice.
Discovery, go at throttle up.
I think many EU countries have VE Day as our Memorial Day. That's fair. 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 Very fair. But yeah, you know, I know that other countries don't do it, and I certainly don't want to come across as like, America, this is the way you do it. I'm not really like that. It's just something I hold near and dear to my heart to keep it in perspective, man. Got to keep everything in perspective. That's very important. Here in Canada, Remembrance Day is in November is the big one. Yeah, Bam, that would be our Veterans Day. Yep. 11th hour and the 11th day. Important. The European guys go, you know, I was about to say it's a really important piece of history, and the Europeans are like, yep, yeah, oh yeah, oh, that was important. Yep. That being said, really have a beer and enjoy time with friends and family. That's my twisted. That's the most important thing. You know, my dad's dad. I never met him. Unfortunately, Lou Gehrig's disease got him before I was born. You know, he was needed somewhere else, as you could say. He was 3rd Infantry Division Mortar Company, and he was at Anzio, 1943. He was there. He was on the front lines. We recently got his service record back because we requested it. And oh man, he has a Bronze Star because so what he did was he went between the mortar pit and the front lines, repairing the communications lines between the mortar pits and the front lines at Anzio so they could coordinate an effective attack. Because the whole point of Anzio, the whole reason why the U.S. hit Anzio and the 3rd Infantry Division hit there is because they wanted the train tracks. So if we just zoom out from Boca Chica for a moment, we go here, go over to Anzio. There's a train track that, like, one of the only, it was at the time, it was one of the only train tracks that connected northern and southern Italy. It's over here somewhere. It like rides along the coast of the mountain, and my grandfather had to make sure that they had the people there had fire support. Which, yeah, you got a Bronze Star for it, which is pretty freaking cool. So we visited his grave. Yeah, it's, oh man, does that make me happy. The anniversary of the Anzio breakout was a few days ago. Yep, they got the damn train tracks, man. It's just like Hearts of Iron, you know? Hey, Mystic, what's going on? Yep. Both grandfathers, World War II as pilots. One flew B-17s in the ETO, and the other flew F-4F Wildcats, then F-4U Corsairs in the PTO. That's cool. That's cool, man. So, my dad's dad was 3rd Infantry Division, and he was in the rear with the gear, which makes perfect sense. That reads correctly for me. And then my mom's my mom's dad served as well, and guess what he was? An aircraft mechanic. Funny how that works. Jeez, didn't see that one coming. You know, like, yeah, of course. He spent his days freaking wrenching on planes and fixing C-47s and B-24s. I'm like, hey, okay, yeah, that reads. that reads. Yeah, that's right. Yeah, that reads correctly. If battling the Italians and Germans wasn't harder. Oh, look, Vesuvius just erupted again. Yeah, right? All fallen. Erudite, yep. Mom's dad survived Pearl Harbor, then fought with the 3rd Marine Division at Bougainville in Iwo Jima. Yikes. That's awesome, dude. That's awesome. During the counterattack, both of your great uncles were one of the units that got cut off by the Germans. Aye. See, Tigris, 3rd Infantry Division. 3ID, the people that landed at the Army division that landed at Anzio, are the people that saved the people that got cut off, the American divisions that got cut off during the Battle of the Bulge. So, pretty cool, right? What I'm trying to say is my granddad helped save your great uncle. Just saying. My dad works for Microsoft. Just saying. My dad doesn't work for Microsoft. Anyway. No, it's cool, man. It's cool. It's good to remember. Family has a long history of military aviation. Great grandfather was the first pilot in the family in 1917. Both grandparents. Your dad flew F4s. You have an uncle that flew B1s. Nice. That other uncle that flew B-52s. A cousin that flew F-16s and F-117s, and another cousin who's still flying A-10s. And then you flew the AV-8B. Dude, that's awesome, man. what a track record. That's great. That's cool. Right on, man. Right on. Your grandfather was considered essential for the LIRR. That's cool, River Turtle. Hey, gotta keep the trains going. Gotta keep the trains going. That's super important. We learned that from Hearts, right? Anyway. Alright, so, I'm gonna put on a pot of coffee here, and then we'll get going. So yeah, check this out. This one from RGV. They're expanding out here. And they, at Starbase, they demolished this, they demolished that, they demolished the... And the crazy part is all these buildings are basically brand new. Yep, that's right. Losers discuss tactics. Winners discuss logistics. That's right. Yep. You ain't gonna get very far if you guys don't have the ammunition to shoot. An army marches on its stomach, indeed. Your best. Losers go home and whine about their best. Winners go home and get the prom queen. Carla was the prom queen. Both uncles eventually passed before I knew them. One from old age, another one from the cancers. That sucks. Pie Guy recently met the child of a person that created liquid rockets. Goddard. Zonic. Goddard is his name. He's from Massachusetts, man. He's from my neck of the woods. That's right. We invented rockets, boy. We invented liquid rockets, boy. Oh, yeah, Twisted. Man, dude. Yeah. 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 Yeah, they, yeah. You know what? I'm holding my tongue. Yeah, you're right. Yep, you're correct. I'll be right back. All right. The old Soviet tactics don't work no more. Yeah, they're Yeah. 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 All right, dudes, let's get to it. I got my coffee, and I'm ready to watch radar. Your uncle threatened to kill me the other day, so that was pretty cool. I love family. What? Um. Yeah, it's gotta be interesting. Yeah, they tried to blitz and it didn't work.
Discovery, go at throttle up.
Tech, tier 245. There you go. Blue, what is the forbidden jello? Please tell me there's some fat, slappy jello noises.
What the fuck is that? Dude? Oh my god!
What the heck? How did... The fat, slappy jello noises. Dude, what did you put in there? How? I'm not even mad. That's a... Synthetic oil with non-synthetic? Dude, it looks like you put axle grease in the oil. Yeah, XJ, I don't think there's any coming back from that. I love those customer states vids on the YouTubes. Dude, me too. Me too, Tech. How cold does it have to get for this to happen? Yes? For memory, there had been a leak in the antifreeze that spilled over into the oil. Blown head gasket. Got it. I think it was brake fluid. That motor's junk. If you tried to start that, you'd immediately clog the oil sump, which I'm pretty sure clogging the oil sump is the least of your problems there, but found that on Reddit, dude. You'd like it, yeah. Yep. Yep. All right. Okay, here we go. Let's see. What do we got? One major announcement by China's space program. Let's see. In the Shenzhou 16 press briefing, the crewed lunar lander is in full swing, including Long March 10, lunar lander, next generation spacecraft, lunar spacesuits, heavy rocket facility, etc. And they said before 2030. Yeah, the blinker fluid. Yep. Mm-hmm. Let's take a look. Yeah, Lenprada. We'll show it again. I showed it on Friday. There's a rover on it, and the rover looks exactly like the LRV. Interesting. Interesting. It looks like they have, judging by this model, I mean, I'm not sure about the fidelity to this model, but it looks like they have a hydrazine, so this would be UDMH and NTO. It seems like they're isolated, because there's a NTO and a hydrazine tank, or UDMH, unsymmetrical dimethyl hydrazine. There's that and an NTO tank right next to each other, and I noticed that each thruster quadrant is basically built around the propulsion, and there seems to be 4 motors in 4 times symmetry, and each one has a redundant fuel system. Well, not a redundant, but each one has a closed loop fuel system on it, which is interesting. I mean, you could do that, sure. I don't see anything glaring here that's like, yeah, that's not going to work. No, I mean, they have thrusters for finer control. Why do the Chinese think they can have this done and ready by 2030? Let's just say the cost of living over there is less than it is over here. And yeah, we'll kind of leave it at that, man. What's up, zombie? How are you? I didn't know rats had feathers. This is a car you're working. Okay. That's feathers in. Okay. I'm not that concerned with this. Yeah, I mean, Dead Scum. Yeah, pretty much, dude. I mean, they're a little less risk adverse than we are. That's all. Yeah, I mean, I don't see why this wouldn't work. It's just interesting that they have a transfer stage on the lunar lander. I'd be curious as to what type of spacecraft architecture they're coming up with here. Yeah. Yep. Marazeus, yeah, or Maraxis, yeah, that's, sorry, I didn't know why I said Marazeus, I know you. I agree. I think that China has something to prove, and I think you shouldn't underestimate somebody with something to prove or some entity that has something to prove. We had something to prove to the Soviets in the 60s, and that's why there's 6 American flags up there. I mean, they're French flags now, but that's why those are there, because we had something to prove. Don't underestimate somebody with something to prove. That's very important. So that's just something to take into account. It's what I've been saying, guys. Like, I have my ethical objections to, like, how China conducts spaceflight, and that's fine. Like, but I'm not going to sit here and say that they're not the closest of anybody besides, like, us to try and get to the moon. Like, you'd be absolutely stupid if you think they don't have the technical competency to do something like this. I think they do. And if they don't, they'll get it. Because that's how they roll. Like, you shouldn't test Shouldn't test nationalistic resolve like that. That's not a good idea. Like, that's... But anyway, yeah, hey, I hope they do it. That'd be great. I hope they do it. They said they'll have everything ready by 2030. I mean, that's a tall order. 6 years to get all that stuff done is a tall order. That's that's hard. That'd be hard to do. What is it? Yeah, I mean, they're dude. I mean, here's the thing, fellas. Like, look, don't test the resolve, right? We said, you know, Kennedy would said before the decade's out that we'll have lunar capability, right? And we barely made it. I know people are going to say, but EJ, didn't we land on the moon in 1969? Yeah, July 1969. 6 months is nothing for a spaceflight schedule shift. That's nothing. That's nothing. We barely made it, and we paid the price. 3 astronauts. We paid the price for it. You know, that's it's something to take into account. Like, I'm not. Look, they say before 2030. That's definitely an ambitious goal. I'm not going to sit here and pretend like it isn't. And yeah, friendly dispatch. I would say Apollo got out by the skin of their teeth. I mean, I'm not trying to undermine the effort that we put in the past. No way. The effort of the Apollo program is insane. It's something that this generation, the generation before us, like no one's seen something like that kind of crazy effort. But you know, if I had to guess. And now, keep in mind, your boy can't predict the future. But if I had to guess, I would say probably the early 2030s is when they'll get it. I mean, like I said, China's not... They got something to prove. They have a massive industrial base. Like, a massive industrial base. The biggest in the world, by a long shot. Maybe... I actually think ours is just a tiny bit bigger. But either way, it doesn't matter. Like, believe me, if China thinks that it's in their best interest to do something like that, they will do it. Yeah, I think that's stupid to say that they wouldn't. He said that by the end of the decade in 61, if I recall correctly, so you could argue that the decade ended in 71. I don't understand how that has any bearing on the conversation, Creeper, because a year is still nothing. That's nothing in spaceflight timelines, dude. It's not much. And I was defining 61 to 70, exactly, because 70 has a 7 in it, and 69 does not. Just something to take into account. The accident literally happened at the best possible time it could have. Yep. But hey, you know, anybody that's going to go out there, like if you want to go out to the moon for national prestige like we did, you know, and peaceful exploration like we did, I don't have a problem with that. No bull crap though. Then we got a problem. What's Europe going to do? They're about to be spaceflight has-beens. Actually, I had been saving this. I had been saving this article for a little while. If you want to pivot to that, check this out. Somebody posted this last week, and I had it teed up. This is Joseph Auschbacher. He is the director of the European Space Agency. Dude, this is brutal. This is brutal. Europe finds itself in an acute lander crisis with a gap in its access to space and no real launcher vision beyond 2030. True crisis force us to reflect on the cause and decisions that brought us here, to come out stronger than before. Read the op-ed. Over the past 5 years, the ESA has paved the way for industrial, commercial, and scientific leadership for Europe in several space domains, most notably space science, Earth observation, satellite-based navigation, and geostationary satellite communication, building up through time a scientific, technical, and industrial capability for which we Europeans can be very proud of. Likewise, up until 10 years ago, Europe also dominated the commercial launch sector. European access to space historically goes together with the ESA's priorities to support our space policy serving scientific, technological, economic, and security goals. Yeah, LinkedIn article, I know. Boomer moment. SpaceX has undeniably changed the launcher market paradigm as we know it. With the dependable reliability of Falcon 9 and the captivating prospects of Starship, SpaceX continues to totally redefine the world's access to space, pushing the boundaries of possibility as long as they go. Once successful, Starship will carry payloads of around 100 tons to low Earth orbit while reducing the launch cost by a factor of 10. Falcon 9 aims to launch 100 times this year, 2023. Europe, on the other hand, finds itself today in an acute launcher crisis with an albeit temporary gap in its own access to space and no real launcher vision past 2030. Fortunately for us, true crisis forces us to candidly reflect on the causes and decisions that brought us here, draw the subsequent and necessarily painful lessons, and come out stronger than before, more resilient, more clever, more visionary, better ingredients, better pizza. Papa EJ's. In parallel to this launcher crisis, we find ourselves on the cusp of a new frontier in space exploration. The discontinuation of the ISS after 2030 and the now graspable and quite tangible exploration of the moon and other celestial bodies is spurring creativity and the onset of completely new perspectives in science, economy, and geopolitics. Ain't that's mo better, mo better. My hope, quite possibly my biggest aspiration for Europe, is that this temporary lack of access to space combined with this moment of novel opportunities and exploration in a rapidly evolving space economy will be the impetus for deep reflection of Europe's modus operandi, leading to a transformation of our overall space ecosystem. But also that the generally accepted position that Europe cannot again lose out on key strategic domains as we did a few decades ago on IT or quantum computing inspires hope that this time Europe will be ready to act and to deliver. Ultimately, I envision a holistic approach for a new European flagship program combining access to space and exploration, enabling increased activities from Europe in low Earth orbit, cislunar space, and on the surface of the moon and beyond. This transformation should be driven by a new engagement model between the public and private sector, including new acquisition strategies and a different role for ESA in the industry to increase pace and cost efficiency. So what do we do now? To place Europe in a leading position in terms of access to space and exploration again, following top priority actions should be undertaken by the ESA between now and 2030. I need to take a drink real quick. First and foremost, ensure the successful inaugural flight of Ariane 6 and the rapid return to flight for Vega C, including a fast ramp-up of launcher cadence and their stabilized exploitation. Once operational, I am convinced that Ariane 6 will be an excellent launcher for many years to come. Continue the performance of Ariane 5 at a significantly lower cost to satisfy European and commercial needs. Two, complement the European publicly funded launchers by mini launchers that emerge as mostly privately funded projects whereby the public sector acts as an anchor customer. Okay. Prepare the 2023 and 2024 space summits, ensuring that all elements needed for a political decision will be available on time, including architectural options and budgetary information, to achieve a wide interest of member states and a roadmap defining the operational capability build up beyond this decade. 4, 2023 to 2024, prepare decisions for the heads of states. Perform comprehensive system studies on the future European space infrastructure, maximizing coherence, cost efficiency, simplicity, synergies, reuse, word salad, and minimize Minimizing operations cost. Ensure coordination with international partners, in particular NASA, and possibly invite other partners. B. Develop the main elements in terms of critical technology, procurement policy, and program roadmap for the next launcher and exploration flagships with a strong focus on reusability, cost efficiency, innovation, and sustainability. Okay. Increase the support of promising commercial European entities. Sorry, I'm just gonna this. Okay, this gets a little long. I'm just gonna blaze through the rest here. Okay, here we go. If Europe is to be once again become a key participant in the new race to exploration, leading in several domains and ensuring enhanced strategic autonomy, then the time to decide and act is now. Forward-looking decisions must be taken at the 2023 and 2024 space summits, as well as the next ESA Ministerial Council in 2025, on a new European ambition in space transportation and exploration, together with concrete actions and developments. I know that we can do this. Let's do it together. By the way, this started today. Oh, Isleman TT. Sweet. It's interesting. Like, okay. So what was his solution there? A public-private partnership and leveraging commercial partners as a backbone to Vega C and Ariane 6? You're doing it wrong. Huh, that's a little strange. His solution was to do the same thing. Yeah, Green, that's kind of what I was picking up on. So basically, his solution is to figure out a plan in 2020 at the 2023 and 2024 space summits. Figure out a plan. His plan is to figure out a plan. I don't. Maybe the silence speaks volumes. I'm trying to think if I missed something there. Did I miss something? Did I miss something? Your plan is to make a plan and plan for that plan to be presented at the 2023 and 2024 space summits. And that plan leverages public-private partnerships and gets Ariane 6 flying and Vega C flying on a reliable schedule. So your plan is to just do the same thing, but he prefaced the entire article with that something needs to change, and then proceeds to say exactly what was supposed to be done in the first place. Am I missing something, dudes? Secondary problem, he put Vega C and reliable in the same sentence. Yeah. Okay, just wanted to make sure that I wasn't the only one. That's okay. All right. Something needs to change. We need to do the same things and get different results. Yeah, that's... Okay. Like, I'm not trying to be mean, but also, like... Sounded to me like they don't have the financial support to do anything, and they couldn't come out right and say the government doesn't pay us enough to do anything meaningful. Yeah. Yeah, exactly, Green. Yeah, that's, Why are you guys making me yawn so much? Why are you guys making me yawn so much? Dang it. Okay. That was an article. Alright, what else do we got? Let's see. We have a new Kerbal challenge here. And this challenge seems to be more up our alley here than just go to this planet and land on it. This one requires building an integrated architecture, which is very nice. Yes, Erudite. Okay. This is the Bug Bonker Challenge. Yeah. Build a station by docking at least 2 Wayfarer habitat modules together in orbit around Kerbin. You're making me yawn. Yeah, well, you're making me yawn. Looks like you might need to play this when it comes out. The creating an engine editor. Yeah, I've seen this before.
Using my new Vulkan game engine. But first I'd like to thank BeamNG, Reyna, Meister, Goldwolf, Jai Morgan, and Snow for supporting me at the Master Mechanic level on Patreon, and Brilliant for sponsoring this video. More about them later. Our story today starts here on the Engine Simulator Discord server. Engine Simulator Official is an interesting place with an interesting history. Around 9 months ago, there were around 60 members on this server, and I just released what I thought was an interesting but mostly inconsequential video about an engine simulation program that I had made. Just a few days later, I woke up to find the server had grown to thousands of members, and there were hundreds of people trying to figure out how to use Engine Simulator, something I didn't even intend to be used as a game, or by anyone other than myself. The Discord server provided a window into how people played Engine Simulator, and what they didn't like and what didn't work for them. I'm still pretty active in the server, I help people with questions, and I just observe how the community is evolving, and how I can make a game that people will actually want to play. What's clear is, Engine Simulator is about more than just engine noises. In fact, I'm not even sure that it's about engines at all at this point, at least not engines from this planet. Engine Simulator seems to be more about expressing your creativity and personal style through machines, or virtual machines in this case. It's similar to how car modders express themselves through their vehicles in the physical realm. So the goal should be to allow players to create a wide variety of airflow-based machines, and being able to hear those creations is just another way of interacting with the game, and it adds an extra layer of immersion. The creation process should also have as few technical barriers as possible. So this would mean replacing the scripting interface used in the Engine Simulator prototype with some kind of graphical interface, which is what we're going to start building today. Thankfully, the game engine is already built and more or less ready to use. I demonstrated the Vulkan renderer I created in this other video if you're interested. To formally start the Engine Simulator game project, the first step is to set up a CMake build script and the project repository. I like to set up my projects in such a way that I can work on the game engine and the game concurrently, since I usually use my own game engines for my projects. I then built some functions to generate and render geometry, and this is critical because most assets in Engine Simulator are going to be procedurally generated, which is not the case for a lot of games. Using these facilities, I generated a grid and axis display and rendered them to the screen. And this looks terrible, for a variety of reasons. First of all, the grid is way too bright, so I adjusted it to be closer to the background color, and that reduces the contrast. The lines far off in the distance are also pretty distracting. Most modern CAD programs solve this problem by using fog to smoothly fade the grid out of view, and I used a similar technique. And it's already looking much better.
We'll see in a second, Stuart.
Most CAD grids are also subdivided into finer and finer spacings. Having just a single grid level like this is a bit amateurish, so I fixed that, and also exposed a new problem in the process. It might be a bit hard to see in a YouTube video, but there are small artifacts where the grid lines intersect each other. This is caused by the grid lines z-fighting. We can solve this by disabling the depth test, but still writing to the depth buffer anyway, and drawing the grid from back to front. This way, the z-fighting is eliminated, but the grid will still appear in front of other objects in the
You know, I don't generally like pausing videos, dudes, but you know when you're hearing somebody say something and you're just like, wow, this person is way smarter than me. I'm having one of those moments right now. Just thought I'd point it out.
scene where necessary.
This
Next,
guy has
I made the
many
fade
wrinkles.
look a bit better and moved it closer to the camera, since I can't imagine anyone using the grid 500 meters away from where they're standing. Finally, I added colored lines to mark the X and Y axes, and now our grid is done, and it actually looks reasonably professional. CAD interfaces are complicated because the user needs to interact with a 3D space using just 2 dimensions.
Yep.
That means we need to project the mouse into 3D space and figure out both what object it should be hovering over, and later what specific point in 3D space it's even referring to.
That's so difficult.
Depending
to get
on which
that right.
working plane we choose, the mouse may be projected to different points in space. But for now, just as a test, I projected the mouse onto the main grid. This is done by finding the mouse's implied position on the view plane and tracing a ray from the camera to that position and following this ray all the way until it intersects with the ground plane. To demonstrate, I'm drawing a sphere at that intersection point. Projecting onto the ground plane is fairly easy, but projecting onto an axis or allowing the mouse to move objects in 3D space in an intuitive way is actually not that trivial. I spent a lot of time studying how Blender does it and reverse engineering the math behind it. I guess I could just look directly at the Blender source code, but I'll leave that for another day. When I first started programming, I found matrix transformations and other 3D math to be really fascinating and something that I wanted to understand more. If you're in the same place right now, today's sponsor Brilliant.org will definitely be able to help you out. Brilliant allows thanks to the most important element of engine video. Now that we have a basic system for mouse projection and rendering primitives
Nice
to the
blue
screen,
fairy.
we can start on what might be the most important element of Engine Simulator's gameplay, and that is the tube. Yes, you heard that correctly.
Tubes. Tube.
Correctly. If you're into engines, then you've probably heard the phrase, an engine is just a glorified air pump. And to some degree, this is true.
Yeah, an engine is a glorified air pump that heats up the air. That's a better way to put it.
From a simulation perspective, an engine
Engines.
is even simpler than that.
Series of
It's
tubes.
reduced all the way down to a network of one-dimensional air channels. A series of tubes, one might say.
A series of tubes.
This
It's like a big truck! God dang, was that guy smart.
simplification is not something that I invented, and isn't some kind of insane, assume a spherical cow type of oversimplification either. It's pretty standard, even in the automotive industry. I feel like I needed to say that for the Reddit experts watching this who don't actually know anything about simulations.
I like this guy. Who's this guy? What's this guy's name? Angie the Great. I like you. I like you a lot. Oh, that guy, man. I like that guy. This guy's cool. Called
The most
Doubt,
intuitive
son.
way of laying out tubes is by first creating a curve and then sweeping a profile along that curve.
Splines.
This is a pretty common operation in Blender using Bezier curves. Bezier curves are pretty simple to implement, so I added those to our user interface, and after a bit of debugging, I got them displayed on the screen. The only issue is there's no way of interacting with or modifying these curves, so we need to add some widgets that show the positions of the Bezier control points. Using the ray projection method I described earlier, we can
Watch.
implement object picking using the mouse. This is a very simple implementation, and in the future I might just use the GPU instead, but this is fine for now. By projecting the mouse onto the current viewing plane, we can allow the user to move these points in 3D space. This viewing plane can be visualized in Blender as well.
Oh,
when I
God.
move the camera to the side, we can see that all the duplicates I made land nicely on this flat plane, which lined up with the camera's previous position.
Yep.
Since all the control points are only visual, moving them doesn't actually modify the curve. So we need to recalculate the curve and update the geometry submitted to the GPU whenever these points are moved. Before we do that though, I decided to simplify the Bezier interface a bit. If you've used Bezier curves in Blender, then you probably know how painful it can be sometimes to get them to cooperate.
I used Bezier curves and splines to make the plumbing on the rocket engines. That's how I did that. You extrude a shape along a line, but see the problem is you get binding like this. If you're from the car world, mandrel bent, same thing, same exact thing. Because you know if you go to bend like a brake line or an exhaust line, it's going to kink. It's going to do that. So a mandrel bent will stretch the metal to give you a nice even shape. That happens in 3D with geometry as well. Yep, see? That's non-mandrel bent, and that's the problem he's describing. See how it's kinked right there? See how it gets skinnier? Really hard problem to solve. Well,
They are very versatile and generic, but this is kind of what makes them tedious at times. I implemented a simplification into the Bezier system to roughly emulate a real-life pipe bender. This makes
I've never seen this video before. I've never seen this video before. Yo! Oh! I'm not as dumb as I think! Yes! Yes! Alright!
creating
Yes!
decent-looking curves much easier and prevents the bends in the tube from looking too unrealistic.
Jesus Christ.
Finally, we can allow the user to extend the curve by adding new points. It's a bit glitchy right now because the program doesn't do anything to prevent physically impossible inputs, but this will definitely be fixed before the game is released. To make these lines three-dimensional, we need to generate a sweep. This means taking a profile and then extruding this profile across the length of the curve. The math for this is pretty straightforward, but there are a lot of edge cases that you have to be aware of. By sweeping a regular circular profile, we can generate the most stereotypical tube variety, which can be used to draw things like exhaust headers, which I'm going to show later in this video. We can of course sweep other profiles as well, like this square tubing, which I'll use later for a rectangle port intake design. For profiles that are not circular, the twist angle becomes important, and it can change the appearance of the tube considerably. For now, the system doesn't allow the user to explicitly specify the twist, and tries to infer a twist angle that remains consistent over the length of the curve. The final tube feature that we're going to add today is a way of controlling the profile scale along the length of the tube. This will allow for the design of simple collectors and horns. To smoothly interpolate between tube scaling, we can use the same Bezier code that was implemented previously. To make debugging a bit easier, I also created a file format to store these curves and load them on startup. This is pretty much all we need to demonstrate how the system will work in the context of the final game.
That's really cool, actually.
We'll start with this mock layout of a V8 engine. The cylinders are just static right now and don't do anything. In the fluid simulation, each air passage is modeled as a one-dimensional channel which can be connected to other channels at a junction. We can use this information to model most of the air channels in this engine. We'll start with the exhaust headers. So headers are usually formed from cylindrical tubes in real life, and there is generally one set of headers per bank of cylinders on a V8 engine. Each of the 4 tubes coming from the cylinder head is called a primary tube, and they usually meet at a junction called the collector, which then connects to the rest of the vehicle's exhaust system, which street vehicles are legally required to have. Using the simplified Bezier system I've implemented, drawing the headers is pretty easy, and the bends actually look similar to what you'd see in real life. The editing process is a bit crude right now, but it will be improved over time. This set of headers is now done, and we can repeat the process on the other side. Next, we can look at the intake. We can use a slightly more square profile for the intake runners, which run from a central plenum to the intake ports corresponding to each cylinder on the cylinder head.
Bonus points if you understand why intakes are square and exhausts are circular.
In this case, I'm modeling a typical dual-plane intake, which actually has 2 plenums. After just a short time of using this system, I'm already seeing many ways of making the user experience better. In the future, each of these parts will be grouped together,
so you
and
don't
the
mix them up.
exposed endpoints will just snap to other exposed endpoints, creating a junction. That way the user can easily exchange common parts like intakes and headers with parts from their own library or that they've downloaded. As you can imagine, being able to lay out fluid systems however you want opens up a lot of possibilities, both in engine creation but also in the creation of other air-driven machines and systems.
That's right, Peter.
If you think that I'm sacrificing accuracy or detail by moving in this more generic direction, you'd be wrong. Underneath, Engine Simulator already supports all of these features, they're just not exposed to the user. In my technical explanation video, I showed a variety of virtual machines that used Engine Simulator, like an air pump and even a simple refrigeration loop. You'll still get the same audio generation that Engine Simulator is known for, but you'll be able to create even more cursed and ridiculous engine designs, which I know is what everyone actually wants. I'd like to thank all my supporters on Patreon and today's
EGR
sponsor, Brilliant, for making this project possible. I'm having a lot of fun and have a lot of cool things planned in the next few months, so hopefully you'll stick around for the journey. Thanks for watching, everyone, and I'll see you guys next time.
There's that sort of... It's mostly because you have to deal with intake air and intake fuel. You're dealing with more stuff, so you need more space because you're dealing with air and fuel, and on the exhaust, it's just exhaust. That's not the only reason, please. Don't go on a Google search. Well, this thing says it's technically... That's not the only reason. That's one of them. You're one of the grease monkeys, Tessa? That's cool, man. And yeah, people have been showing me Engine Simulator for a little while. It's actually pretty neat. EngineSim.parts. What is it? This is a real-time internal combustion engine simulation designed specifically to produce engine audio and simulate engine response characteristics. It is not a scientific tool and cannot be expected to provide accurate figures for the purpose of engineering or engine tuning. The basis of all 3D modeling. Tubes. Crap! Tubes! Tubes! There's automation, yeah. We could mess with automation if you want, dude. It's like, I'm curious to see what this offers that automation doesn't.
Discovery, go at throttle up.
So what's on the menu for today? What?
Discovery, go at throttle up.
What? I don't know what I'm doing, Tom. I'm so scared right now. It's not okay. Okay, Marcus. Whoa. Try to repair manual and failed. Any suggestions? What are you trying to fix, Dan? You have to put it in gear? my push mower engine, but you have no experience. But you said you failed. What's up? Oh, I see. Failed to find a repair manual. Oh, okay. What type of mower engine is it, dude? The reason why there's no repair manual is because it is absurdly simple. Like, cars are about finding the... Like, you can't be overconfident because then you're going to break something. But you also can't look at it and be like, nope. You can't get overwhelmed either. You just kind of got to take it for what it is, dude. It's a B&S Craftsman. So, okay. Do you know what's wrong? What's wrong with it? Why doesn't it do? Why doesn't it do, my guy? Yeah, DSM, you see the dude, this thing is actually pretty legit, man. The pressure graphs, you can see the chamber pressure and whatnot. I just got to figure out the controls with this. But yeah, we got a 4-rotor there. I'm gonna make a 318. We'll make my 318 in the Coronet, or the 302 in the truck. And right now it's a 2.2 liter 4-rotor, 133 cubic inches. But you saw why 4-rotors are really cool, because they can rev to the end of time. Just that thing went to 9,000, no problem. Just you know. I don't know enough to know what's wrong. It's 20-year-olds and runs rough. I'd like to take it apart, replace replaceables, clean it up, and put it back together. Okay. All right. Hold on. B&S lawn mower engine. I can tell you right now, with probably about 90% certainty, that it's your carburetor. The carburetor is caca. Also Briggs & Stratton. Yep. So, all right, here. So you need a new carburetor. It's the needle and seat or the float in the carburetor. They get old. Go on eBay and buy a new one. That's it. That's it. So, Dan, you know how it's really easy with an aerospace project to get involved and get more involved than you need to, and then you find that the whole thing is apart and it stays apart for 10 freaking years, and then you don't, it takes a little while to put it back together? Fix it first, then make it look nice. I mean, I would also like to disassemble and rebuild it as a learning experience. Okay, so here's what you do. Replace the carburetor. Get that thing running. Go to the dump. Go to the dump, junkyard, whatever. Find the junk lawnmower engine. Take that one apart. Trust me on this one. That's how I started learning. That's how I started doing it. So trust me. Do that. Trust me on this one. Or if you don't care about the Briggs & Stratton, you have another lawnmower, just take that one apart. Screw it. Doesn't matter. I only have very basic combustion engine knowledge and zero hands-on experience except running them. Okay, you need a set of tools, basic set of tools for the lawnmower engine. Lawnmower engines are simple, easy peasy. They're not, dude. This lawnmower engines are about as simple as you can get for an internal combustion engine. They are absurdly simple. It's a basic 4-stroke. That's it. 4-stroke flathead, most of them, easy peasy. Yeah, go to the junkyard and find one, dude. Preferably find one that is the same or similar engine to yours. Take it apart. Put it back together. See if you can get it to run. That is how I started learning when I was 15, 16 years old. That's what we did in my auto shop. We had an auto shop at the school, right? It's still there, but yeah, I don't really go over there anymore. But they started us off by, taking apart a lawnmower engine and putting it back together. Seeing if you can get it to run with no prior hands-on experience. That's what see if you can figure it out. A lot of us couldn't. I did. I figured it out. Actually, lawnmower engines and mini bike motors. Mini bikes are where you start. Even a bicycle, dude. Even like a pedal bicycle. That'll get you the basics, dude. Oh, yeah. Single simples. Yep, yeah, dude. Bikes, scooters, mini bikes, dude. Even old Honda motorcycles. Like Honda motorcycles, insanely easy to fix. Yeah, but dirt bike engines are 2 strokes, Tigris, so they're... Yeah. 2 strokes a little bit of a different game. Start with a rock. Yeah, right. All right. So, fellas, Engine Simulator isn't actually listed in any category. I'm trying to switch us over to Engine Sim. It's not there. So I'll just keep us on science and technology and we'll call it a day. Just call it, yeah, we'll keep it in sci and tech. I went to a tech high school for diesel mechanics. We used to tear down motors to the block and rebuild them with no gaskets or oil or radiator and run them for a couple minutes with a hose and a can of fuel. Yep. Yeah. Den, what you got to figure out is that this stuff is easy. It's not rocket science, okay? Like, this is something that I have trouble with. I have trouble with this. A car is not a frigging rocket, okay? The engineering tolerances aren't nearly as precise as you need them to be. Now, with that being said, there are some components on an automobile that have to be right or else you're going to have a bad day. Like crankshaft balance, for instance. That has to be right. The motor will run. It just won't run very long. But a lawnmower engine, dude, lawnmower engines do not care. They are not... They are like the simplest of the simple. They don't really have to be efficient. They're not like, you're not worried about your miles per gallon with a lawnmower engine, right? Like, it is about as simple as you can get for engine design. I mean, dude, maybe I'll go find one from the dump or something and take it apart. We'll do it on stream or something. Maybe, but yeah, take it apart, take another one, go to the junkyard, get one for like $20. They're not going to cost too much, okay? I sent you a PDF on Discord a while back with good info on small engine stuff. Do you want it again? I think that got lost in my DMs, Electron. Not to be disrespectful, I apologize, but I don't seem to remember that. Oh, there's my gift that I sent you back when I was on my bachelor party that I can't share with the class. Okay. Yeah, it runs well enough to get the job done, but I'd like to be able to maintain and repair yourself. Good. Den, that's good. That's good that you want to do that. Rebuilding your own stuff is freaking awesome, dude. I love that independence, man. I love it. Dude, you know how many people came over the other day and like the party? I had a party over the weekend and everybody was at my house and they saw the Cornet and they saw the truck and they're like, "You did this?" And I'm like, "Yeah." They're like, "You did this in here?" I'm like, "Yeah." So? And they're like, "Holy crap, dude, can you fix my stuff?" I'm like, "Yeah, bring it over." Being able to fix your own stuff is awesome. I personally, like, don't get me wrong, not everybody's going to be a hands-on son of a gun, all right? I get that. I'm not trying to say everybody needs to do this. Fixing your own stuff is awesome. Being able to fix it and being able to get it running, get it working, right? That is the gnarliest feeling ever. So yeah, dude, you want to learn? Go get a junkyard engine, take it apart. Dude, you know what's messed up? I got a lawnmower engine rebuilt, and then so what I did in that auto shop class, I went to the junkyard, and so there's, lawnmower engines are a little bit different than like a go-kart motor. I wanted to make a go-kart, right? Every kid wanted a go-kart, right? I couldn't afford one. because I'm a kid and my parents were not buying it. So I went to the junkyard and I actually found a motor that has a horizontal drive shaft. All right, so what's the difference here? What's the difference? Lawnmower engines have a vertical drive shaft. Think helicopter, because lawnmower blade, right? The drive mechanism on the lawnmower's wheels are a belt drive that goes off of the engine, and the belt turns 90 degrees to your drive mechanism. Why? Once again, because of the lawnmower engine. So I actually went to the junkyard and I found a go-kart engine, and I rebuilt the go-kart engine and I got it to run. I still have it. I think it's at my parents' house though. I still have that motor. The orange the orange motor. The orange motor. I remember the day I started it up in school, and all the other kids, this is like freshman auto shop class. All the other kids in class were like, "It's running, it works." I'm like, "Yeah, what do you mean?" Yeah, of course. I was ready to buy a new mower. Screw that. That Briggs & Stratton will never fail you if you know how to do preventative maintenance. The Briggs motor won't fail you. Dan, you remember a little while back, dude? You remember a little while back I had my neighbor gave me his old mower, and it has a Tecumseh motor in it, the snowblower, and I fixed it because the Tecumseh motor is never going to die. That motor will survive a nuclear blast, and it'll just keep going. Good luck repairing a vendor-locked machine that will lock itself as soon as you open it. Everything's fixable with a sledgehammer. Paying my mechanic to fix my last car annoyed me a bit, but given that the problem was not what I thought it was, that feeling didn't last long. Diagnosing a car figuring out what's wrong with a car, King, is a little bit more difficult than, like, a piece of software. A piece of software usually tells you exactly what's wrong, but it only tells you exactly what's wrong if it's coded to tell you exactly what's wrong. Cars are like that in that regard. It's not exactly the same, but it's kind of similar, right? Cars will not tell you. Nowadays, cars have codes, and they'll tell you kind of what's wrong. They'll tell you the area. Like, it'll say, oh, the car has a bad sensor. But just because a car has a bad sensor doesn't mean that replacing the sensor is going to fix it. Now, does it? No. It could be a bad sensor because something broke that sensor, right? So, yeah, then, diagnosing it is the tough part. Usually doing the work that's the easy part. So that's why the first thing I asked Den here, what's wrong with your mower? What's wrong with it? Dude, honestly, Den, what you could do, I bet you your motor's just gummed up. It's gummed up from fuel. Put some Berryman's in there. Just put some Berryman's B12 in there. Clean it right out. That's basically like a nasal decongestant for your engine. And that's it. Take the air filter off, pour that in there, and it'll shoot out some white smoke, but yeah, you're good to go. Diagnosing the car is the hard part. Fixing it is the easy part. Bingo. Spelling, please. Berryman's B12. You can get it at, it's fuel injector cleaner. You can get it at any automotive store, and heck, most hardware stores. New Pope confirmed. Yep. I was told that it was missing a seal on a power steering pump. Turns out it was a rack and pinion issue. So, King, don't say. Let me guess. So, it was leaking power steering fluid, and the rack and pin most likely sprayed fuel onto the power steering pump. Because if it's leaking, it's under pressure, so it's going to shoot out like a squirt gun. And it probably shot fuel over your power steering pump. And that would lead you to believe that it's the power steering pump. But it ain't the power steering pump. See, that stuff, that's why cars are a little bit more difficult. But you can still tell if you really know what to look for. That takes practice. There's no instantly getting good at that. You know what I mean? Hopefully not fuel. Oof. What's the difference between the motor you named and a normal two-stroke motor? Alucard, this? Look at it. Does that look like a normal engine to you? This is a Wankel engine. Are you talking about that? That's Wankel. That's German, man. Wait, hold on. Yep. Felix Wankel. Yeah. Yeah, this is not... That's not... Yeah, that's not how a regular engine works, man. You said fuel, not power steering fluid. Yeah, fuel. I meant fluid, sorry. Going too fast. Yeah, Alucard, this type of engine here is called a Wankel engine or a rotary engine. Rotary engines are different than radial engines. Radial engines are like an airplane motor with the pistons that go all the way around. If you look, that's a four-stroke. It's a four-stroke engine. But Felix Wankel came up with the idea of having an engine that's basically a rotated. They call it the spinning Dorito. That's the slang term for it, right? A spinning Dorito. Okay? Now, the spinning Dorito, I mean, it's a triangular shaped rotor here, right? And basically what it does is it takes the intake air, the intake, which has fuel in it, it's air and fuel, and then the triangle, because it's spinning, it's spinning eccentrically on the crankshaft, right? It basically takes it over here, compresses it, right? And then there's double spark plugs that blow it up, and the explosion actually pushes the triangle back this way. It basically pushes it along that eccentric axis, right? And then it shoots it out here. The thing about these types of engines is that the apex seals are the weak point. Basically, see where the A is? The points of the triangle are the weak point. But the advantage of a Wankel engine like this, okay? The advantage of this type of motor is that because the triangle doesn't... Basically, the triangle doesn't veer too far. The triangle doesn't veer too far away from the center axis, all right? So what do I mean? Okay, if you look, it's just riding eccentrically around on the crankshaft, doing this, right? Just, right? Because literally the center of mass of A doesn't stray too far from the center of rotation from B, you have a very short throw, so this engine doesn't put a lot of moment on it. Now, that is the reason, that right there is the reason, it doesn't put a lot of moment on the crankshaft. That's the exact reason why motors have rev limits. There's certain engines can only rev so far because, honestly, like if you have this big piston that's going all the way up and coming all the way back down and going all the way back up again and coming all the way back down, there's only a certain speed before the crankshaft can't basically pull that piston back down and push it back up fast enough. The momentum of that piston going up and down, the stroke of the piston, will just break your crankshaft. Torque always finds the weakest link, right? So engines have rev limits, okay? So the idea here is that this Wankel engine, this is what makes the Wankel engine good. A doesn't stray too far from B. Okay, in this diagram. So Wankel engines they can rev to the end of time. You can rev really, really fast because that triangle literally isn't going very far. Look. Crazy, right? You can rev it to the end of time, right? So that's what Wankel figured out. Genius, really, really smart. All right, hold on. What other engines do we have here? Or can I make one? How do you make one? Back when F1 was good. You had the 787B idle sound for a second, Baboon. I was thinking about... So sometimes, dudes, I use these discussions just as an excuse to... Nope. Sometimes, dude. Sometimes I just use it as an excuse. Oh, I love that noise. Make an engine requires some coding. The dev put out a video earlier today showing off the progress. Yeah, Trainman, that's what kind of sparked this whole discussion. What track is this? Oh. Okay. Here's the thing, guys. If you can get any internal combustion engine to rev higher, it will make more power. All right? But you have to reliably rev higher. Any engine can rev to 10,000 RPMs. It's just not going to be in one piece after that. Some of them. Look at those numbers. See? The triangle doesn't move that far from the center line. The 2.6 liter engine produced 700 horsepower at 9,000 RPM. See that? Extremely small displacement, insane amounts of power, because even if you rev a 2-liter engine to 9,000 RPM, it will make power. Oh, it'll make a lot of power. Oh, absolutely. Isn't piston momentum and throw the reason why I think it was Porsche made the crazy tiny cylinder V38 or something? Correct. Well, that's why, so Aqualex, that's why, okay, so now you just... You know how there's people that like big old muscle cars, like blah, 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 blah. And then there's like folks that like imports or cars with smaller, lower displacement engines that can rev higher, like the fart can cars, like, you know, like that's your difference. So like say, okay, I'm going to date myself. Say somebody has like a Honda Civic, right? An old Honda Civic. Those Honda Civics can rev really, really high and they can make a lot of power. They just don't make a lot of torque. But the car is light, so it doesn't matter, right? Compare that to, say, like the Mustang, for instance, or my truck, or my other truck, right, or the Dodge. Those motors don't rev very high, but they make a lot of torque, so they can accelerate fast, but they don't go very fast. The Honda, on the other end, doesn't accelerate very fast, but it can go faster. You know, that's kind of the difference between, like, what people like with cars. Some people prefer, like, the smaller, higher revving, lower displacement engines, because especially if you take one of those small boys and you put a turbo on it, then you have an insane, you could, or even like a supercharger, you can overcome the low torque figures because it's a tiny little motor, right? But there's also, if you put a supercharger on something that makes a lot of torque, you will go faster a lot quicker. Your top speed won't be as high, but you can change that with gearing and stuff. Why not both? Yeah, me, DSM? Yeah, exactly. I'm a little bit greedy. Why don't we just turbo the bigger motor? All these differences can be compensated for with gearboxes. It's all engineering, man. To load engines, go to the game directory, assets, and engines. There's some nice stuff. Okay. Alright, let's go over here. Load engines. Desktop. Tube simulator. Yeah. Oh, this is gonna sound dirty. That's sick, dude. There's the duty cycle. That's awesome. I think that's what that's called. Oh, that's cool. Yep, that is what it is, dude. And if we slow it down, oh, that's cool. Oh, that's cool. How come there's no torque and power? Oh, that's hypnotic, dude. Something about an engine running just makes me happy. You have to put it on the dyno. Oh, okay. Oh, that's cool, man. Read the controls? Why? I don't want it. It's not my wallet. Dude. That's cool. The duty cycle on it is awesome. That's so cool. Look at this graph! Makes me happy. Why'd you guys show me this? Why'd you show me this? Damn it! Alright, shut her down. Why'd you show me this? Alright, where are the controls? Is it Taxi? What's up? Show the Hemi gimmick. Wait, what? I'm not sure. In my high school diesel shop, we had an old diesel engine off a mushroom farm that was donated to the school. We got the thing working so well, we could have the valve cover off and could turn down the timing to the point where we were watching individual valves firing off. Yeah, that's cool. Alright, where's the controls for this sucker? Where's the controls for it? Here we go. Thank you. What wankles? Something fun for you Ford fans. Okay. Where is deferred? Gone. Oh, no, wait, it's off for a second. Oh, yep, there it is. Oh, dude, that Granada is money, man. I love it. I love it. I love it. I love it. Why do I like sedans so much? It's so strange, Robert, but that's cool, man. Sounds like a, I'd say a 2.3 if I had to guess. It sounds like a 2.3 liter. But it's had a little something done to it. If I'm hearing those minty Ford noises correctly. Yeah, you hear that noise that it's making? Yeah, that means it's had some... It's a buddy of yours, and it's a 2JZ. Oh, even better. Hey, I was close with the displacement. I was close. Wait, there's a 2J in a Granada? There's a 2J in a Ford Granada? Dude, I don't hate it. I don't hate it. I don't hate it. I don't hate it. No. Everything about that says I shouldn't like it, but I mean, can't argue with results, my friend. You can't argue with the results. I mean, can't argue with the results. Am I right? All right, let's see what's at the end. Oh. You're gonna need to visit the tire shop. Dude, I like it. A freaking Granada with a 2J in it. That's money, dude. Ford should have made a car like this. Ford should still make a car like this. This is great. I love the BBS rims, dude. I like everything about that, man. That's cool. Yeah, the Capri. That's not what I mean, dude. I'm talking about Tessa. I'm talking about Ford should make something again like the Escort Cosworth or the Cortina Cosworth, something like that. You know what I'm talking about? Just a little snappy, like type car. You know what I'm saying? Sierra car. Oh, my unicorn. I will own one of those, dude. I will own the Kazi because it's a Kazi. Just anyway. The only thing that could be comparable is the Hellcat. Screw LS swaps, 619. 5.7 Gen 3 Hemi swaps are my new best friend. Those are my favorite rims in Gran Turismo. BBS wires, dude. You can't lose the BBS wires. All right, toggle ignition, hold for starter. TU increase, decrease clutch pressure. Wow, you can get crazy with this. QWERs change the throttle position. Dot is the brakes. D enable dyno. Okay. Boop. Dynamometer enabled. Okay, so ignition. Turn the key into the run position. Turn it into the start position. This is called Engine Sim, General Baden. Hemis are already in the 3rd gen. The 1st gen Hemi came out in 1957. I think it was 57. Called the Chrysler Firepower. Yeah, it's in the 3rd gen. Give me 1 second. I'm still trying to figure it out for myself. Give me 1 moment. I'm going to move over a little bit so you guys can see the AFR. Alright, ready? most part, panroofing, yeah. This thing, you just gotta watch the torque, man. Torque numbers. That's crazy, dude. Dude, look at, oh my goodness. Yeah, I made it mad. I pissed it off. We may have broken something. How did... All right. If you could get a small block Chevy to spin at 7,000 RPM, that's not a motor for the street. Did I disable the rev limit? Yeah, most likely. And we most likely just broke something. Made 1,300 foot-pounds. Yes, it is. 7K isn't that high. For a stock 3rd gen small block, because that's what this is. It's a 3rd gen small block. I've been looking at the numbers here. Alright, shut her down. Ooh, she's dieseling a little bit. Yeah, see, do you see what we did there? That would have broken it. We would have broken something. A stock 3rd gen small block can't rev 6,500 Hellfish. I mean, I don't think it can. I'm pretty sure it can't, dude. That's a 4th gen-ish big block. I mean, 3rd gen big block. Sorry, excuse me. The 454 that came in the Z71s, the GMT 400s. That's what this is supposed to be, I think. It can, just briefly. What other engines do we have? Engines. V69, ATG Video 1, Audi. Oh, there's an Audi 5. Nice. BMW. M52. Is that a Supra? Is that a Supra? Chad, is that a Supra? Slow it down. 1, 5, 2, Oh, it's 153. So that's 15362. That's the firing order for a 2J, isn't it? Well, not a 2J, an M58. So 1, 5, 3, 4. No, 1, 5, 3, 6, 2, 4. Interesting ignition cycle. Oh, this is dope, dude. It's a mid-90s engine. I don't know absolute snot about BMW motors. All right. Unpause. Rev it to the roof! Oh, it didn't like that. I wish my engine went vroom. All right, S. I'm actually serious about this. Hold on for a second. What are you doing? What are you doing this weekend or the next weekend? Nothing. Okay. Talk to Brimo, and we'll see if you can come up here this weekend, and we'll figure out what the heck's going on. Is there a rotary engine? That's what we started with, Void Ray, yeah. You know what this makes me want to do? It makes me want to play automation. Should we mess with automation, dudes? Because Engine Sim is kind of... Dude, the potential for Engine Simulator is sweet, but I always like building... I like building engines in automation. That was fun. We did that one time. Actually, you know what we should do is go actually start the truck engine. I've always been curious about automation. Okay. This is awesome, though. This is really cool. I really dig all this, man. Try the Audi first, the inline 5. This is the Quattro motor. Inline 5-cylinder. All right. Ignition is enabled. Dynamometer engaged. Get some gas.
Discovery, go and throttle up.
Hey, Kathop, 10-month resub. Ready? Put it in first. Oh, I stalled it. Stalled. My bad. Here we go. Power! Oh my god! This thing is sweet! Give me 1 second, Forge. It's beautiful. It's beautiful, chat. Look at it. Look at it in all of its glory. It's just sitting there. Just sitting there at 4,200 RPM. Whatever. Uh-oh. I don't know what it is about motors, but something about motors that just calms me down. I think it's naturally aspirated, STX. I don't see... Yeah, see, look at the dyno. Very linear. Or very not... See, blah. It's not... Okay, so the dynamometer is showing... See these lines, how they're pretty straight? It's there was a turbo on this thing, these lines would do something kind of like that. It would go here and then it would go up there like that. I think it's a naturally aspirated i5. Either that or I'm not using it right, which could also be a possibility. How does this sim work? Is it a single cylinder, or is it that's just for visualization? Here, let me slow it down. It'll make more sense. This is an inline 5, so 5 cylinders inline. So the second cylinder is firing. And then... Warning, danger to manifold. Shut up! I'm gonna hit this freaking 2-liter Mitsubishi engine with 150 shot of nitrous. Nothing bad will happen. Danger to manifold. Shut up! You know. Alright, so let's see. I don't really do dynos too much, dude, so let's start her up. And the floor pan flies off. I mean, okay, to be honest though, you can have your manifold pressure. You can actually blow welds on an intake if you run too much turbo pressure. So if you don't have your blow-off valve, configured correctly, you can actually blow welds on an intake. But that's not when you're making happy time. That's when you let off, and the engine starts to down rev. And if the turbo RPM isn't correlated to the engine RPM, basically the turbo isn't feeding the engine with the right amount. You usually have a blow-off valve or a wastegate, and that's what makes the noise when you let off with a turbocharged car. If you don't have your blow-off valve configured correctly, right, that turbo is going to try to literally stuff air down the engine's throat, and the engine will not have it. And you will blow the welds on the intake. I've seen it happen on YouTube. I haven't seen it happen personally, but... Well, not me personally, but a guy I know. He blew the welds. Woo-wee! No, he didn't. No, he didn't. But you can imagine what it'd be like if he did, huh? What causes overboost? I've heard that term, but I don't know what it is. Basically what I'm talking about, dude. So, okay, you have a turbo on a car. You have a turbocharger. What does the turbocharger do? It's a jet engine. That's what it is. Just think jet engine, okay? So think all the gases going out of a jet engine. What that turbocharger does is, like, you picture a jet engine in your mind, you picture it shooting out a lot of hot gas, right? It's shooting out a lot of air, a jet engine, right? Now, don't get me wrong, a turbocharger is not the same as a turbojet, but just get that picture in your head of accelerating a lot of gas really, really fast. What the turbo does is it's basically a jet engine. You have a compressor and you have a turbine. But instead of having an explosion, right, blow stuff up and then it shoots out the back turbine, the engine is your combustor in this design. So the thing here is that the compressor is going to be feeding a certain amount of air, right? And the engines have airflow rates. So in the US it's cubic feet a minute, CFMs, all right? I don't know what the European one is. It's probably some millimeters per cubic millimeter squared per kilograms, something. I don't know how you guys measure airflow. I don't know what the unit is. So, right? So basically what happens is if the turbine pressurizes your intake, right? So the compressor on the front of the turbo pressurizes your intake, okay? So it's forcing air in. And it basically forces air down into the engine when the engine is revving high. But the engine can change its revolutions per minute a lot faster than a turbine can change its RPM. There's no brake on a turbine unless you have some type of rotor brake. But basically, if you let off the gas, right, and that turbo is still spooled and it's still delivering power into the engine, you'll screw up your air-fuel ratio and blow the engine. Because it'll force too much air in, and because you took your foot off the gas, you're not delivering enough gasoline or whatever, and your engine will go very, very lean very, very quickly. If you put too much air in and not enough gas, your motor overheats. something like that, consort. I'm not sure. Cubic meters a minute is the metric equivalent. Yep. Okay, Forge. Can you granny shift it? Granny shifting is, let's see. Well, in Fast and the Furious, Vin Diesel says, "Oh, you're granny shifting, not double clutching like you should." Double clutching and granny shifting are two different things. You can float shift something, which is basically where see, okay, here's the thing. Like, you can granny shift stuff basically where you just put through the gears, you don't put the clutch in. But that's floating the gears, right? You can do that, but that's something that applies to, like, trucks. You don't really do that with cars. The reason why is because cars have synchronizers in the transmission. They have synchros. And the synchros in the transmission basically make it so you don't have to do that. Basically, a clutch, when you shift the gears, it moves forks, like little forks back and forth, and those forks push gears back and forth. And in order to get the gears to mesh correctly, to change the gear in the transmission, the front of the gear has a tapered synchro on it. So basically, before the gear pushes up against another gear, it'll start spinning at the right revolutions per minute, so the teeth match up, right? You double clutch something to rev match in a non-synchronized transmission to get the teeth to match. If you don't do that, you'll basically try to shift and you'll grind the transmission. You'll hear the gears going grrrr, and hence the saying, grind it until you find it, right? So also in drag racing, flat shifting, like not lifting off the gas, is what's needed, not double clutching. Yeah, granny shifting and floating through the gears and double clutching are something that semi trucks do. You don't need to do that with like a Mitsubishi Eclipse, right? So Paul Walker in that first Fast and the Furious race has an Eclipse GSX, which is a really cool car. It's got a 2-liter turbocharged engine in it, and it's all-wheel drive, which kind of makes me think, why would Edwin and that other guy, the dude with the PS2 in the car, why would they think their B-18Cs could go up against an Eclipse GSX and a Mazda RX-7? That's beyond me. You know, in the movie where the guy's like, "Oh, damn, that guy's fast." Yeah, it's a third-gen RX-7. It's got a turbocharged Wankel motor in it. Why did you think you would win? I don't know. Whatever. Yeah, exactly. You would just rev match, consort. That's right. You would rev match in a car. You don't need a double clutch. But yeah, he says, "Oh, I'm surprised the 100 shot of DOS didn't blow the welds on the intake." No. That won't blow the welds on the intake. The 100 shot of nitrous, if you give too much nitrous to a motor, you give it too much freedom, you're not gonna blow the welds. You'll blow the head gasket. Yeah. And if your ignition timing isn't right, it could blow the welds on the intake. But once again, if it was going to do that, it would be when you let off the gas. Yeah, melt pistons. So what happens is, guys, okay, so something to understand with internal combustion engines. You have your pistons. Your piston is going up and down, right? So see the piston going up and down? Okay. See those 3 ridges on the piston right there? Those are piston rings, okay? There's usually 3 of them in just a regular up and down piston-y motor, right? So the one on the bottom is an oil ring, okay? That prevents the oil that's basically shooting around all over the crankshaft to keep her lubricated, right? That's preventing the oil from going into the combustion chamber, okay? So the oil ring is there, and then the 2 rings on top of that are compression rings, okay? The compression rings are basically a piece of metal that looks like a giant C, all right? And then you have this thing called ring gap, all right? The ring gap is exactly as stated. It's how far apart the ends of the C are, right? If you don't have your ring gap configured correctly for nitrous or a turbocharger, you will quite literally explode the engine. The engine will visit Valhalla, hopefully in a blaze of glory, right? Now, why? Why is this a thing? So, when you're delivering nitrous or you have a turbo into a motor, you have to make sure that your air-fuel ratio is right. Okay, what does that mean? Air-to-fuel ratio. So, there's an ideal amount of air and fuel, usually 14 to 1, give or take. 14 air to 1 fuel. All right, there's an ideal amount at the molecular level of how much air you should put in and how much fuel you should put in. Now, so take imagine you take a regular motor, right, and you start spraying nitrous into it, right? That's going to make the motor go way to one side, right? It's going to go way to one side in your air-to-fuel ratio. Why? Because nitrous is an oxidizer. Think like rockets. It's an oxidizer. It's an oxidizer that's 33% oxygen, okay? Compare that to a rocket, which is 100% oxygen, right? Because they're using liquid oxygen, right? Compare that to natural aspiration, which is our atmosphere, which is 21% oxygen. You up your oxidizer content from 21 to 33, okay? So that means more oxygen is getting in the engine for the amount of air that you're flowing, right? If you do that, there's going to be more oxygen getting in there. All the fuel is going to combine with all the oxygen, and you're going to have oxygen left over if you don't deliver more fuel with more oxygen, all right? So what's going to happen? So the explosion's going to happen, and then all that extra oxidizer that's in there is going to absorb all that heat. And then the engine block by proxy is going to absorb all that extra heat because you completely blew up all the fuel. This is called lean. Running lean is very fuel efficient because you blow up all the fuel. But also your engine has a higher operating temperature because you blew up all the fuel. It's going to absorb, the engine and the extra oxidizer absorbs all that extra heat. So your engine runs really, really hot. What happens to metal when you heat it up? Anyone? Anyone? Thermal expansion happens. You remember those piston rings that I told you about? They basically get so hot, they expand and then they close. When that ring closes, if it has no more room to close up, right? It starts expanding outward inside of the cylinder. This kills the engine. This kills the motor. That's what happens when you spray too much nitrous into an engine or you have too much turbocharger. The motor will lean out and you'll start melting things. So what's going to happen is two things. Depending on what your engine block and what your piston is made out of, the ring is either going to go out, because remember, these rings are very, very strong metal. They are designed to hold the explosion inside of the piston, right? They're designed to hold it up there so it doesn't go down into the crankcase, right? Those things are made out of very, very strong metal. Most likely it's stronger metal than the engine block or the piston, unless you have like a built engine, right? In which case it can take it, right? So the piston, that piston ring is going to expand outward and crack the engine block, or expand inward and literally squeeze your piston and crunch it like a freaking rock. I've seen it happen. An expanded piston ring can actually crack a piston in two pieces. And if you've cracked a piston in two pieces, that's the end of that. Yep. You're screwed. You better hope that no pieces of that piston are going to gack the block or anything, or gack the cylinder wall. Because if that happens, junkyard, scrap metal, right? So, yeah, if you hit the side of the cylinder, so this part right here, with any component that's failed inside of there, so oftentimes there's water behind it. So there's a water jacket behind this for cooling, to cool the combustion chamber. That's why you have a radiator. If you gack it in such a way that actually starts putting water into the piston, well, guess what? Engines are designed to compress air, because air is a gas and gas is compressible. Water is not. So now water's in the piston goes up, tries to compress the water. Water says, nah, you're not doing that, and the piston explodes. Yeah. Oh yeah. There's a really good channel on YouTube called I Do Cars that tears down engines that have failed, and you can see the carnage that it causes. It is unbelievable. Engines are a carefully controlled balance of physics. If one of those things goes too far out of whack, the physics, the simulation starts to break. Yeah. Most modern plastic OEM intakes can take about 30 psi before they kaboom. Yeah, plastics, what do you want? That's how you turn a wankle into a mankle. Yeah. Well, so the weak part, like I said, the weak part with a wankle motor is the apex seals, okay? So we go down here to rotary engine, 4-rotor. The weak part is the tips of the rotor. That's the part that fails on rotors. There's a piece of Inconel, believe it or not. It's an Inconel tab that's right there, right there, right there. The reason why it's Inco is because heat. If the Inconel tab melts, you die. This kills the motor. Change your oil. Yeah, exactly right. Meet Mr. Rodney. Yeah, you'd go visit Rodney. That's right. Yep. So, like I said, it's like what we said when we loaded up Engine Simulator today. Engines are air pumps. They heat up air. And all air pumps do heat up air. I do understand that, but it heats up air. That's the heating part. If you heat it too much, the air gets angry at you. So basically, running lean is better than running fuel-rich for car motors. Running lean is more fuel-efficient. Running fuel-rich, the opposite side of that. So if you deliver too much fuel, right? You'll successfully use up all your oxidizer. You will make more power, right? But it's not very efficient. You're not very efficient because unburnt fuel is going out the back. That's called running rich, T-Man. Now, here's the thing. You know when Raptor engines turn green? Watch. See the Raptor, one of the Raptor engines in the Starship footage right here. The exhaust turns green. It turns green because the rocket engine went lean. Because what a rocket engine does and what a piston engine does is not that far off. They're both heating up gases and accelerating it somewhere. Now, a car will accelerate it against a piston and use the piston to go down, right? A rocket accelerates it out the bottom of the vehicle, right? So, here's the thing. Some rocket engines run fuel-rich on purpose. They run fuel-rich to keep the temperatures down because even though it's very inefficient, it's the only way to prevent the rocket engine from melting itself. They use that in the form of film cooling. Raptor does that. Raptor film cools all over the place with fuel-rich mixture to make sure that it doesn't turn green. When a Raptor engine turns green, when the exhaust turns green, that means you got a big problem because the motor is getting too hot and it's melting the engine from the inside out. The reason why it's melting the engine from the inside out is because Raptor has milled copper cooling channels inside. The cooling jackets for the Raptor engine are made out of copper. If it burns green, you're burning the cooling system. And if the cooling system goes, the rest of the motor will follow shortly after. No problem, Breezy. Shooting flames out the exhaust because I'm rich. Yep. Juicy 15-month resub. Yeah, that's all we could tell when like SN10, SN9, SN8. We could tell they all had problems right away because of the exhaust. And that's why I constantly say you can tell if a rocket engine is healthy just by looking at the exhaust. Heck, if I could see the explosion inside of a car motor, I'd be able to tell you if it's okay. It's just how the explosion propagates. You'd be able to see it just fine, right? Thoughts of seals made out of SX500 or another one of those SpaceX super alloys? I mean, it'd work, Steinert. We need fuel rich because unfortunately we are still in fundamentally material technical debt. We just don't have the right materials to do things nominally. Alex, I would argue that that's probably never going to happen because thermodynamics is annoying. It's funny. I always attribute the laws of physics and the laws of thermodynamics to basically like playing Tetris. You never really win at Tetris. You don't win. You just kind of get better at it over time. You know? And you can find better ways to play, but you're still going to lose. You still lose eventually. That's engineering in a nutshell. Now, just like Tetris, right? People still do engineering because it's fun. People play Tetris because it's fun. Tetris is a great game. Fantastic video game. One of the best around. One of the interesting parts of the power equation in piston engines is shaping the flame front. Yes, Hemis. So the funny thing, aircraft piston engines can run what's called lean of peak, aka having too much oxygen instead of too much fuel. Basically, they're playing on the other side of AFR versus temperature chart. Do you have a favorite Tetris map? What? Tetris map? Hard start scenario, Katra is most likely. Can you explain a Hemi? Sure, Pop, absolutely. Give me 1 second. T-Man, what do you mean Tetris map? Favorite Modern Warfare 2 map? I don't know. I'd have to go look at the maps again. Yeah, Hellfish, I know. Isn't Favela Black Ops, Void Ray? I don't understand Tetris map, T-Man. Tetris is there's no maps for Tetris. There's just an open cylinder. Level? Have you ever played Tetris before? Anyway, all right, so okay, Pop, a Hemi, right? So what's the idea behind a Hemi? Okay, it's a hemispherical combustion chamber. Why? So why would you have a hemispherical combustion chamber? Okay, take a tennis ball, cut it in half. Hemispherical, half of a sphere, right? So the combustion chamber is if you took a tennis ball, sawed it in half, right? And your combustion chamber is shaped like a dome. Okay, now why? Why would you do that? Picture the shape an explosion makes in your mind. Like anything. Like if you had a firecracker on the ground, what does that shape look like? What does the shape look like? Hemisphere. There you go. That's it. That's all you need to know. That's it. The Chrysler Hemis from back in the day had a hemispherical combustion chamber. With the hemispherical combustion chamber, you basically take most of the outward force of that explosion and you're using more of that force to push the piston down, because explosions are spherical. So making the combustion chamber spherical on your car made it so more of the explosion can be used to push the piston down. That's the important thing to understand. That's Hemis in a nutshell. Funny thing is, dude, most engines do that. Nowadays, most of them do. But you have a little bit of a weird problem, all right? You have a weird problem with Hemis, right? Or anything like that. You see how the small block or the big block Chevy right here has a flat combustion chamber, right? Some combustions, so like with a Hemi, for instance, right? You have a valve, and that valve is flat on one side. See the exhaust and the intake valves? See, they're flat? They have to be, because they have to make a seal. It's tough to take that flat shape and make it into a conic shape. It's tough to have a conic valve. Don't get me wrong, it can be done, but you see what I'm talking about? So the Hemi engine basically has your valves at 45 degrees off the combustion chamber. One valve is this way, and the other one is that way, and the chamber is hemispherical. Could you also sort of think of it as a bell nozzle but pointed at a piston and a cylinder? Kind of. I bet the older Hemi design would work great with today's direct injection. Yep. The fact that Tetris was made by a software engineer, by an engineer, really explains why that is, honestly. Yep. Mm-hmm. Is it true that Ford took a lot of design for the LS motor for the Godzilla? It's more convergent design at this point. I mean, if you're going to make the argument that Ford's 7.3 engine is basically a big block Chevy in LS form, I think it's safe to make the argument that GM, with their LS engine in general, copied the 351 Cleveland, because they did. Guys, they copied it so much that 351 Cleveland heads can actually, no, what was it? LS heads can fit on a 351 Cleveland, if I'm remembering right. It could be that. There's some kind of thing that makes them very similar, but whatever. Put the Hemi on the piston head and not the block. Why would you want to do that? Okay, so this gets a little complicated, right? We're getting into complex geometry here. So here, let me show you. So you have your combustion chamber here. You have your piston right here, and then your connecting rod goes down here like this, right? And then up here you have the head, right? And the heads on the Hemi are like this. They're hemispherical, right? And then you have to have a spot for your valve here and here, all right? So what you're saying is make the piston concave like that. Now, here's part of the reason why cars, like, I said, like, you don't get better, you just kind of soldier through it, you're always going to lose. Okay, so making the piston like this, right, concave like the head, right, you make an explosion, right, your explosion blows up here. You have some gases that are pushing this way, some gases that are pushing that way, some gases that are pushing this way, this way, this way, this way, and that way, right? Seems like a good idea. Remember, the explosion needs to push the piston down because an engine takes the piston's linear action and converts it to rotational action, all right, around the crankshaft. See? Now think about this for a second. So the explosion's job is to push that piston down. How does this air pushing outward in this direction on the piston, how does that push it down? How? How does that push the thing down? See what I'm saying? So this gets into trigonometry. Cosine theta, exactly. You're getting into trig here. Basically, a force that... Oh, no, not save. A force that's pushing this way to get this kind of motion is very inefficient. That's not going to do anything. So why not have your piston circular, and when the explosion goes this way, right, these gases up here will basically compress up against here, and that'll force the gas downward. Because that's what you need to do. You have to see, this is what I mean. It's just basic shapes. How do you take that spherical explosion that's blowing up in three dimensions and make it go to 2 dimensions, right? Now, don't get me wrong. With that being said, there are... convex cylinders, but they're on diesel motors. Diesel motors are an entirely different thing, because a diesel explosion is a little bit different than a gasoline explosion, right? Why not more efficient rotational electric motor? What? Where? What does an electric motor have anything to do with an internal combustion engine? I'm confused. What are you talking about? We're talking about how this is all theory of internal combustion engines. We're talking about zebras and you're going, yeah, what about giraffes? What about giraffes? I'm confused. Ron Turbine, now, like I said, there are ways to kind of fudge it a little bit, but yeah, basically you have to get a spherical explosion into an up and down motion, and that up and down motion makes rotational motion, right? I'm not saying there aren't better ways to do it. I'm saying it's hard to get that explosion. You're trying to use the most of that explosion to push the thing down. You literally push piston down with explosion. That's harder to do than you think. It's not just, oh, make the piston concave. That doesn't fix it. Would a conical top be better than a hemispherical one then? Wouldn't that help direct more force downwards? Let's look at a pair of LS heads, shall we? Wolfie, what's that shape? You're not far off, dude. I haven't seen it. 619. Oh, interesting. Oval pistons from Honda. Cool. See what I mean? Yeah, the cone actually, basically what you're trying to do, guys, is get all the gas to compress up against the top of the cylinder head. And when that gas compresses, it pushes downward. The problem is when you compress that gas, a lot of it turns to heat because of the ideal gas law. And this is why engines need a radiator, because they get really, really hot. Right? Wacky idea on the piston. Yeah, one piston, two connecting rods. It's interesting. But yeah, it's all a balance of forces, dudes. But the thing is, like, here's the really difficult part with a car. No explosion is going to be exactly the same. Think about that. All those little explosions going off inside of the engine constantly just none of those explosions are ever going to be perfectly uniform. Ever. They're all going to explode in a slightly different way. So that's something to kind of understand with internal combustion engines. That's something that's really hard to get right. It's really hard to get it to explode in the same exact way every time. Could you make an electrical crankshaft? Linear generators reciprocating because of the linear motion of an opposed two-stroke free piston engine. What benefit would that have over a regular electric engine? Hey Razzie, what's going on? Yeah, Alex. Yeah. There's some pretty interesting stuff being done here. But yeah, not electrical. Internal combustion engines do get a little bit, they're not inefficient per se, because there's nothing that can achieve parity with them right now. But they're the worst except for all the rest, if that makes any sense. Razzie, your beavers are going to make you crazy. Yeah, great engine conversations, dude. Hang on, I just want to... Sum it down now. Not off the top of my head, Signer. I just like sitting here and hearing this noise. This is a big block Chevy, Raz. static compression versus dynamic compression. Yep. Do a rev match downshift. It's hard to do with the keyboard, but I'm telling my brain to rev match and my at face value. I'm like, oh, feet. Nope. There we go. There's this kind of new simulator out, Jim. It's actually it's not new. I know it's been around for a while. It's called Engine Simulator. You can learn a lot about how engines work from this thing, which is actually pretty rad. Jim, Jackal, I'll be honest with you, that kind of messed with me a little bit because I had to think about, like, okay, what do you do to rev match? Okay, clutch in, throttle up, downshift, clutch open, let go of the throttle. Like, I had to translate that to the keyboard, and that just screwed with my head a little bit. That was difficult, man. That screwed with me for a second, man. Connect your pedals? Yeah, right. Right, Shaw? Isn't that cool? Yeah, it's automation. This is making me want to play automation. Oh, Storm, Jackal said downshift, and I'm like, what? How would I do that? I love, dude, that sounds like a big block Chevy. That's what they sound like. It's great. It's such a good noise. Oops, I stalled. Okay, let's get a dyno pull. Guys, I'm having trouble getting the dyno to read. I'm probably not doing something right. I'm having trouble getting that dyno to work correctly. insert squeak, squeak, squeak from a real motor. Yeah, okay. Would it be cool if they added aircraft motors with constant speed props where you control power with manifold pressure rather than RPM? Yeah, I mean, I guess the guy is pretty... The guy that's making this is going to add all kinds of cool stuff. You'll be able to build your own motors. He's building a UI right now to be able to make your own engine, so you could do it. All right, what's that Artemis news? According to the Spanish Ministry of Science, they'll sign the Artemis Accords tomorrow in Madrid. Nice. How many presets are in here? Right now, we have an Audi inline 5, a BMW inline 6, a Chevy 454. Kohler? I don't know what this is. Oh, a V2. All right, let's... Basically a motorcycle engine. It's a little bike engine. Look at this. That's a bike engine. Doesn't rev really high, but still. Yeah, I mean, it's basically 2 cylinders from a V8 that's just 2 cylinders. So that's why it doesn't rev a lot, because it's tough to move. It's tough for this one engine to just keep moving these damn pistons around. What's V69? It's taking a second. V69 is a 420 liter engine that makes 25,632 cubic inches. Okay. I don't even want to know what type of starter you're going to need to make it do this. What the hell? Let's I'm gonna go back to the Chevy motor. Hey, where'd you go? Come back. Now it's on my other monitor. Please hold. It's on my other monitor and there's no way to move it. Exit. There we go. That was weird. Funny how that sounds just like your inline 6. Your engine should be sounding somewhat like this. Actually, yours would be a little bit deeper than this. Nice. Neato. It sounds like a 5-banger? Well, funny you should mention that. Kind of in 4th. Yeah, okay. It's tough making your hands do what you should be doing with your feet. Just put the keyboard on the ground. Problem solved. Not yet, Rezel. Audi made a lot of these. Come on, baby, get up there. How come that poll didn't read? I'm not doing this right, dudes. I'm convinced I'm not doing it correctly. I'm at 20% throttle? Was I not? You gotta put the pedal to the floor there, idiot. Alright, let's try it now. That's strange, dude. I must not be. I'm pretty sure I'm not doing something correctly here. Here, let me load up the Chevy engine. I'll know what to do with that thing, because V8. I'll use the big V8's torque to compensate for the fact that I have no idea what I'm doing. Okay, so dyno enabled. Okay, ignition on, start. Engine simulator. It's pretty cool, you know, sign. We're messing with a big black Chevy right here. Can this teach you how an engine works? Kind of. Kind of, dude. I mean, this will teach you about the physics behind it, if you want. I mean, guys, if you want to do like a thing on four-stroke cycle, I can do that. It's not that difficult to understand. I'm just kind of like, I think I might have a case of the dumb. Give me 1 second. Wouldn't it be awesome if you could import this engine into BeamNG?
Go and throttle up.
I mean, you could do that with automation. Maybe the i5 isn't acting right because it's actually a 15-degree V engine that is only not flying apart or ripping apart the motor mounts because it's got a couple of big balance shafts. No, Synerd, something that I find with stuff like this is not to blame the equipment. It's usually not the equipment's fault. You don't know what you're doing. That's like 90% of why people break cars. Yeah. I mean, mechanics, back me up on this. I've actually noticed that it's very rare that somebody actually breaks a vehicle unless, like, they crash it or something. Usually when stuff goes wrong, it's because of lack of maintenance or whatever, or somebody doesn't know how to use the vehicle correctly. That's usually why stuff breaks. I'm just saying it's not properly simulated. The engine itself in real life works fine. Possible.
Discovery, go and throttle up.
There you go, Zarby, yeah. Collectors call that patina. Yeah, right. Interesting. Alright. Engine sim's cool. I like that. As that gets better, I want to mess with it more. But, yeah. Yeah, Panderific, once again, I'm having trouble making my hands do what my feet usually do, if that makes any sense. So like I said, it's most likely. Sorry for the repeat, trying to get info. Have you used Beam with automation? I have automation in mine Beam. It'd be cool to build a car and then drive it. Do you know if it works well? Is Beam worth the purchase? Beam is worth the purchase, Twisted, yeah. Yeah, I actually used Beam to teach people about different suspension types one time. Yeah. What I would do in Beam is I would take a car that has no business doing a certain application and then make it do that application or figure out a way to make it do. So like I made a van, like a Ford Econoline van, basically into a hill climbing vehicle. And then what else did we do? We turned a truck into a dragster, which trucks you can do dragster things with, but also, yeah. Yeah. Yeah, we would take cars that have no business doing certain things and make them do those things. Yeah, the windbreak. Did you see it fall over, Thomas? How about that guy up on the lift, dude? Yeah, that's basically what it is, dude. Yeah, Beam is awesome, and it's a soft body simulator, which is cool. But anyway, that was a good little thing there. That's a fun little game. I'm not sure right now. There's not much. I'm gonna say not much replayability to it, but yeah. They cut it in half, push it in half, push it in half. Sad to see it go. Yeah, whatever. Whatever, man. The factory that's going to replace it is going to be better. As I thought, someone used Engine Sim to create an engine sound for a car mod. Dude, yeah. Chlor, I remember when somebody linked this. Somebody linked this to me in chat. Let me see. Whoa. Boxer motor. It's a it's a Porsche engine. Okay, a 992 Porsche motor. I was gonna say 4-liter horizontal 6. It's a Porsche motor. So, Twisted, you see that? That's an automation. That's an automation car. It's a car that was made in automation that was put into Beam. Okay, when do you crash it? Oh, don't tell me he doesn't crash. Oh, talk about a freaking letdown, man. Damn. Downloading Beam right now. Beam is fun, man. It's a good game. All right. Anyway, that was a cool little tangent there. Are you guys down for some cities? Beam videos without crashes. I know, right? That's so strange. Let's go work on Canalsterdam Heinendok. Alright. So I'm going to switch this over to cities here, and then let's roll.